So when Connor rings Kira's house, the probability that Kira answers the phone is 1 over 5. So that means that the probability that she doesn't answer the phone will be 4 to 5. Because there's only two outcomes. She either answers the phone or she doesn't answer the phone. Connor rings Kira's house once every day for 7 consecutive days. Find the probability that she will answer the phone on the 2nd, 4th and 6th days, but not on the other days. So she will answer the phone on the 2nd, 4th and 6th days. So this is a nice straightforward probability. If you just do yourself, there's 7 days, 3, 4, 5, 6, 7. She does answer it on the 2nd, the 4th and the 6th days, but not on the other days. So the probability that she doesn't answer it in any given day is 4 over 5. That she does answer it is 1 over 5, and just fill in accordingly. And multiplying all of that together, should give you 256 over 78,125, or 0.0033 correct to 4 decimal places. Find the probability that she will answer the phone for the 4th time on the 7th day. So we can do this as a Bernoulli trial, because we don't know there's any number of ways that she could answer the phone Monday to Saturday. So she's successful for the 4th time on the 7th day. So if we just look at this again, so if we just do our 7 boxes again. Now, so this is going to be the 4th time on the 7th day. So from these first 6 days, what we want is we want 6, or there's 6 days there to do it, and we're looking for 3 successes. So we're going to frame this as a Bernoulli trial. The probability of success for her, so I'll just write out the formula for Bernoulli trial, N choose R. P can be thought of as success, so R successes, and then that means that you'll have N minus R failures. So for example, in this case, if we have 3 successes, we'll have 6 minus 3 failures. So the probability of success is given to us. It's 1 over 5. So we're looking for 3 successes, and we're looking for 3 failures. But then on the 7th day, she does answer the phone, so that will be 1 over 5. Now, putting all of that into the calculator will give you 256 out of 15,625. Okay. Now, Connor rings her house once every day for N days. Write in terms of N the probability that Kira will answer the phone at least once. At least once, the way we do this is we do 1 minus the probability that she doesn't answer it at all. So what's the probability that she doesn't answer it at all? Well, we don't know how many times this is actually going to be done, so that's why it says in terms of N. So think of it as a Bernoulli trial. We're going to do something N times, but we're looking for no successes. And remember, the probability of success is 1 over 5, and we're looking for no successes. And we're looking for all failures. So the fact that he would do it all the time, so it's not 0, sorry, and then that this will be N. So again, it's 1 minus the probability that she doesn't answer it at all. That's how we work out the at least once. It's 1 minus the probability that it's not done at all. So if we work our way through this, we have 1. Now, n choose 0 is 1. Only one way to do that. 1 over 5 to the power of 0 is again 1. And then we just have 4 over 5 to the power of n, which gives me, in terms of n, that value there. Find the minimum value of n for which the probability that Kira will answer the phone at least once is greater than 99%. So the first problem we have here is the fact that it's written as 99%. So we need to change that to a decimal, so we're just going to change that to 0.99. So we want it to be greater, so we want the probability to be greater. So this is the, right in terms of n, if we just look back at this last one, the probability that Kira will answer the phone at least once is this value here. Okay, so it's that value. That's the probability that she'll answer the phone, and we want that to be greater than 0.99. So we want 1 minus 4 over 5 to the power of n to be greater than 0.99. Now, take the 1 across and subtract it. And that will give you 0.99 minus 1, which then gives you minus 0.01. Now, we have minuses here, so multiply both sides by minus 1. And remembering, because it's an inequality, that will flip the sign. This is now a logs question. We have a to the power of x and y. So we can rewrite this. We can do log to base a, so if we just move up here, log to base a of y equals x. So our base is 4 over 5, that's a. X is n, and y is 0.01. So log to base 4 over 5, which is 0.8, of 0.01, that will give me x, which, so just as a calculator works, so log to the base 0.8 of 0.01 gives me 20.63. So find the minimum value of n. So the minimum value of n is 21, because you can't actually ring the house 20.63 times. You either ring the house or you don't. So tough enough question there in parts C and D. It always is in terms of when it's asked in terms of n. But just remember, the probability that it will be done at least once is 1 minus the probability that it's not done at all. Okay.